Okay, so here we're going to calculate the volume of an irregular solid. So the terminology of irregular solid here is referring to the fact that we have a three-dimensional rectangular prism, but if we look in the picture, we see that there is a cylinder that's missing inside of it. So it's an irregular type solid that we're looking at. I did my best to draw this picture, but I also have a video of me showing you a real life example of something that looks similar to this. So hopefully that'll help you get a better idea of how we can calculate the volume of an irregular solid such as the one that I drew here. So let's look at what this would look like. So what I did is I cut a hole in this box and I put my cylinder right here. And if I were to fill this rectangular prism with, well, this used to be a magnet box container. So let's say that there's a bunch of magnets in there. Or let's say we even could fill it up with water, and maybe the water is supernatural water that doesn't ruin the cardboard here. So if we were filling up this shape with water, this cylinder part would make it hollow. There wouldn't be any water on that part of my rectangular prism of this odd object. So if we think about how we're going to calculate the volume of this thing, we want to take into consideration that we have something missing in the center, and that's the cylinder. So we could move this cylinder. Think about the fact that I have this rectangular prism, and then I'm essentially right here I'm just going to remove the cylinder out of my rectangular prism. So consider that concept as we calculate the volume of what would be able to just fit in this part of the rectangular prism. All right, now let's try to calculate what we have. Okay, so here we are back at our picture. Let's think about what we have. We have the volume of our rectangular prism, right? And then which would be the spot that it would hold the space of whatever it is that I have inside. And then I also have the volume of my cylinder, which I want to remove because it's in the center and it's not going to hold any space if I were to fill up the this solid. So I have the volume of my cylinder, and I'm not going to finish spelling that because there's not that much room. So volume of my prism is going to be area of the base times the height. Volume of my cylinder is also going to be area of the base times the height, but I'm going to take into consideration that my base is in the shape of a circle. So when I write this formula, I'm going to put pi r squared times h. So for the rectangular prism, you decide which part you want to be the base. That's a decision that you can make. I'm going to highlight this bottom part to be my base. And I'm just thinking of the rectangular cylinder part. So this entire part would be my base, right? I'm including that circle because I'm just focusing right now on the prism. So the shape of my base is a rectangle that has a length of 4, and then over here this would also be 10. So the area of my base is going to be 4 times 10, and then my height is the distance between my two bases. So my other base would be this rectangle at the top, right here. The other 4 by 10 rectangle above it that's parallel to it. So if I'm calculating the height, it would be how far apart those two bases are, which is also 4 units. So we have 40 times 4, which is 160. And now I'm going to subtract the cylinder part. So if I focus now on my cylinder, we have our circular base at the bottom. So let's do that in blue. Here's my circle base. I'm going to be removing the cylinder, so I'm just kind of highlighting here what we're getting rid of. And let me just go ahead and color in my cylinder. This blue cylinder is going to be taken away from my prism because it's hollow in the middle. So I have pi, my radius. So think about, I did not include that in my picture. Okay, let's say that my radius is, I'm going to say that my radius is 2. This is a number that I just created right now. So my original drawing at the beginning of this video doesn't give you really enough information, because I would have had to also share with you that I have a diameter of 4, which means that I have a radius of 2. Okay, so if my radius is 2, I have 2 squared, and then the height would be the distance between my 2 circular bases, which is 4, and we're getting that 4 from this side of the prism. This side of the prism is going to match up with the distance between these 2 circles right here. So we have minus pi, 2 squared is 4, so 4 times 4 is 16. So then the volume of this entire irregular solid would be 160 minus 16 pi, and volume is 3-dimensional, so that would be cubic units. And if I wanted to put that into my calculator just so I can give you more of a numerical value, I'm going to round to 3.14 for pi. So I have 160 minus 16 times 3.14, and that gives me about a volume of 109.76 cubic units. All right, and I apologize at the video for not putting the information here on the radius of my cylinder, because there really wouldn't have been enough information to solve. So hopefully that's going to help you understand how you can calculate the volume of an irregular solid if something is missing. Or let me just draw one more example. Let's say that we had another, and this is more of a composite solid. If I had, say for example, a cube, and then maybe on top of that cube I have a square pyramid. So in this case, if I were calculating the volume of this entire thing, I would want to add my cube, whatever volume I have for the cube, plus the volume of my pyramid. And that would give me the volume of the entire solid that I have here. It's a composite solid since it's composed of the pyramid and cube. All right, I hope that was helpful.